Welcome to Creative Learning. Today in this video, we shall discuss about relationship between frequency, time period and wavelength. Before we begin, subscribe our channel for future updates. Now let's begin. Now let's begin. You know that the sound waves about how they travel. Sound waves travels in solid, liquid and gaseous medium, and sound waves is produced due to vibration of different objects. Now let's study about frequency, time period and wavelength. In this video, I am drawing a graphical representation of sound waves. Now you just see how sound waves is produced. And this is time and this is sound waves or wave disturbance, how sound travels. When there is a disturbance, the sound wave travels like this. And this is one complete oscillation or vibration produced in a medium. If this is medium, then the oscillation produced or vibration produced is called time period. Means time taken to complete one oscillation is called time period. Time taken to complete one oscillation is called time period. This is one complete oscillation. As like pendulum, time taken to complete one oscillation is called time period. Next, what you see is, imagine if sound waves travels in a density or pressure of a medium. This is how about sound travels in number of oscillations. So this kinds of number of oscillation or vibration present in a sound waves per unit time is called frequency. Means number of oscillation or vibration in a density or pressure of a medium is called frequency. Number of oscillation or vibration per second is called frequency. SI unit of time period is seconds and SI unit of frequency is hertz. We denote it time period as seconds and we denote frequency as hertz. Next we discuss about wavelength. Imagine if this is a slinky. What happens is, when I compress it, it goes compression. When I release it, it goes rarefaction. If it goes rarefaction, then observe that how I compress this. Now observe that number of compression or rarefaction produced. Now observe here, this is a compression and this is a rarefaction. Observe here, this is compression and this is rarefaction. The distance between two consecutive compression or rarefaction is called wavelength. The distance between two consecutive compression or rarefaction is called wavelength. And SI unit of wavelength is meter or centimeter and it is represented by lambda. This is lambda and its SI unit is meter. Understand? This is nothing about wavelength. I take a sketch pen in order to compress this slinky. Now how it goes compress? Look at here. When I release, it goes rarefaction like this. The distance between two consecutive compression or rarefaction is called wavelength. Next we discuss about relationship between frequency, wavelength, time period. If V is the sound wave and F is the frequency and lambda is the wavelength, then relationship between frequency, wavelength and lambda is given by speed of sound waves is equal to F into lambda. V is the sound wave, speed of sound wave. Speed of sound wave and F is the frequency and V is the lambda. Sound means vibration produced in a medium and SI unit of sound is decibel. SI unit of sound is decibel and relationship between sound wave frequency and wavelength is speed of sound wave is equal to frequency into wavelength. Imagine if this is a speaker, if sound travels, then speed of sound travels in number of compression or rarefaction like this. Sounds propagates as density or pressure variation. Sounds propagates as density or pressure variation. So this kinds of the distance between two consecutive compression or rarefaction is called wavelength. Thank you for watching this video. Hope you like this video. Subscribe and share with your friends.